Thank you to everyone for being here. It's awesome. And also thank you to Dystopia Labs for putting this event on. They turned on the weather machine for Portland for this time of year, so it's definitely been awesome that there's some sun. Normally it's pretty rainy around these times, so I'm very happy and grateful for that. My name is Tom Hay. I am a product manager with Infura. If you don't know what Infura is, we are a product that provides access to Web3 networks, and we provide high availability APIs as a way to access those networks. So if you're trying to access the JavaScript object notation, remote procedure call, API that is part of built into the Ethereum protocol, like we provide access to that without you having to run your own infrastructure. Or if you're looking for a fallback, we also can serve as like a fallback for you if you are running your own node infrastructure. But today, I'm here to talk to you about 8-bit arcade games with reward and high score mechanisms. So in this talk, we're going to go over some of the concepts that are related to old school arcade games' high scores. And we're going to look at some solidity. I wouldn't worry too much. We're just going to high level talk about the solidity. Don't worry about it too much if that's maybe you're like, what's going on here? And if you know it really well, this is what I call debugging with friends, where someone just yells out like, hey, that's not what, that should be this. So that's always really informative. So my hope is that we can kind of unify these together and get some ideas going. This is a hackathon. There's more hackathons coming. So I think this is a really interesting topic, especially as like gaming. We've thought about gaming in this space, and I'm very old school in my gaming habits, as you will very soon find out. But first off, story time. Before I joined Infura, I worked at Consensus Academy and was also on the developer relations team. And so one of the highlights of each year is that we would have students from the Blockchain Developer Bootcamp present their projects, and that we would like see them and see what they were working on. So, and actually, there's at least one presenter here today who is a graduate of the bootcamp, which is really cool. There might be a couple more. In 2020, one of our students created a project called Proof of Snake, which is like the best name. And so this project was super clever because it took this old school game and said, like, what happened if you would actually try to put that onto Ethereum? Like, what would you have to do? And it really explored that idea. So if you scan this, this will be the link to the GitHub repo for the student who did this, Sean, who is amazing, awesome. Huge shout out to Sean. We'll actually be doing a series about this that kind of dives in deeper and expands upon this talk over the course of April and May on our blog. And if you want to, if at any point in time you kind of zone out a little bit, this is the link to the game. So if you have like MetaMask Mobile running, you'll need Rinkeby ETH to play it. So go to your, go to like the MyCrypto faucet, get some Rinkeby ETH, go ahead and try and beat that high score. So when I was growing up, there used to be actual arcades in malls. And when I was a kid, it was places like Time Out, Chuck E. Cheese, laser tag places. I don't know if anyone remembers Time Out. This was like the big mall era when you would go and you could like play every single game that was made from like the 70s up into the early 90s. And you would put in a quarter or a token and you would play a game. And that game sometimes would print out tickets that you could redeem for like a bouncy ball or something that would immediately get lost on the car ride home. And it was kind of cool. It was probably spent more time in these places than I care to admit. But it sort of seeing Proof of Snake like reminded me of these moments of going to a pizza place and there being the side-scrolling Teenage Mutant Ninja Turtles fighting game, right? And you would see at the end when you lost in like level 1 or level 2, you would see the high scores of the other players who had played that game. And you'd really wonder why Bob or Ant, or it was only ever 3 letters that you got to put in, would be the high score winner. Like, what did they do to get that high score? How did they go, fight Shredder on the final level? And this like still exists today. Like, you can go to a lot of arcade places. I'll get to that at the end of the talk. But like, before I got into this the wonderful world of Ethereum and blockchain, I worked for a school district, and at that school district, at the end of the year, we would always have a party to sort of, raise the spirits of the teachers, and a local Dave & Buster's would would open up before they would open for the day and allow us to play the games, give us all the free cards, so everyone would like camp out in front of Time Crisis and try to beat it because they had unlimited plays, which is like an impossible game to beat. So this really like awakened something in me, this game and that Sean made, and it really got me thinking, like, how do you, using sort of some of the code that Sean did, some of it I've modified to sort of break this down, like, how would you actually do this? There's been a lot of talk about gaming in the space, and sometimes I feel a little passed by, and I was like, let's bring it back to like the fundamentals that I'm familiar with. Put a coin into a machine, play a game until your lives go to 0, right? So this might be useful if the one thing I'll say, do not assume this solidity is non-exploitable. Like, this is not, none of this has undergone a formal contract audit. In this blog series, we'll start to go through like how you would do that. So I just want to put that out there. Like, this is really cool stuff, but I would for now like keep it on a test net. So the first part of it is this idea of coin operation, right? So Sean, in his game, you are going to put in this coin, this quarter, and you're going to essentially access this function called play game, right? So when I'll switch back real quick if you want to just check out the link to the game so you sort of get a sense of what's going on. But it will prompt you to connect a wallet, and you will then have to basically pay the game fee. So this function play game is being called. It can accept Ether. It's because it's public payable, and he was requiring to accept a certain amount of ETH to take in this game, so to start playing this game. So we've kind of stripped that away. You can see that game dynamic. So before you can start to try and see how long you can get your snake to build, how many essentially pixels you can eat without running into your ever-growing tail, you first have to put in this coin. So this is the approximation of it, of what that is. We're going to build on this function. So we're going to come back to this in a little bit. But this is one way, if you're thinking about how to build in games where someone has to pay in order to play, this is one way to do that. So we can then start to think about another dynamic, which is tracking the high score. A little bit of a history lesson here. I came across a Wikipedia citation from the International Center for the History of Electronic Games, and that's like now on the Wayback Machine. I don't know that wonderful organization still exists, but it claims that Seawolf, this is Seawolf, if you don't know what that is, was the first electronic game that actually tracked a player's high score. So Seawolf was released by Midway in 1976. Before that point, if you're a big pinball fanatic, you're probably aware like pinball machines have tracked high scores for a while and often had a reward mechanism if you hit a certain high score. But this was like the first arcade game according to this article, that actually tracked your high score. And when you beat the high score, you would like get an additional play. And there's actually all this sort of interesting lore about how in different malls or places of the game where there would be like runs on quarters or whatever the local currency was to be able to play this game. It was getting so popular. So you should be able to see it at the link at the bottom. Like there's a whole website called the International Arcade Museum website. If you want to go back and check out a bunch of like old school games or just Google that, it's really cool. It's a very interesting trip down memory lane. According to this article, also Space Invaders, which I hope I don't have to explain what that is, but you're basically shooting down at spaceships that are coming at you, and it is the first game that the high score would not be like reset. So it was actually stored in memory. It wasn't just like as you were playing and continuing playing. If they unplugged the machine, it would keep the high score. And then finally, it wasn't until Starfire came out that you could actually enter your initials. That 3-letter, like enter your initials of the game. So we're going to talk about the high score mechanism. The way that Sean approached this was he not only kept track of the current high score in an unsigned integer, which he called high score, and then also the address of the current leader, which was stored in a variable called address current leader. But he also, and this will come into play later, because there's a really interesting game dynamic that starts to turn this on its head from just being like, hey, let's recreate classic arcade game mechanisms, to being a little bit more like what we would say like the promise of Web3. He created what's called a mapping, right? So like being able to create key value pairs that keep track of an address and the pot balance. So in this function of new leader that gets called when the high score is beaten, it's going to assign the address of whoever currently beat the game, who's connected to the game, message.sender, you can see that there. And it's going to set them as a current leader and also set the high score with that temp variable underscore score. Lots of scores in that sentence. The mapping is now important because if you beat the high score and you need to keep track of like who paid into this game to play it, the winnings, everything that's gone into the game now gets split between the game developer, the owner of the smart contract, and the high score winner, right? So now we're putting in this idea of like, how does Web3 change this? Because back in I mentioned the ticket mechanism of old school arcades, of Chuck E. Cheese. That was kind of, trying to incentivize people like, oh, if you get 1 million tickets, you'll be able to buy an NES, and that like never happened. And that NES is like probably still there, and it's the one that gets auctioned off on eBay because it's the original one that they bought in 1989 and had behind the counter. You can actually very quickly start returning what's paid in for this game to the players of the game. That's really kind of cool, right? You're incentivizing people to play, and there's something there for them at the end. But you're also, as the game developer, able to get a reward. Now, this is a simple approach of it. It's basically divide by 2, right? Divide the pot in 2, give half of that pot to, or assign it within the mapping. That half of that pot is assigned to a key of the current high score winner's address. The other gets assigned to the owner of the smart contract, an address that we'll get into that in a few more slides. But assign that back to that owner and then allow them to actually get those winnings. So we're now starting to sort of change the way that we think about these old school arcade games. There is some really cool things that we can do. We're also opening ourselves up to the potential, because we're writing, we're writing Solidity, and we want to be able to give the high score winner the ability to withdraw their winnings. We're going to have to implement a mechanism for them to actually take that out of the game. And before we get too far down this path of all the ways that withdrawals can be exploited, I do think a really great source material, if you're learning Solidity, if you're writing Solidity, particularly Solidity 0.x, whatever version above, the Solidity documentation has a really good explanation of a common pattern called the withdrawal mechanism, withdrawal function. It talks about an old project called King of the Ether. You pay in, and whoever's the highest payer is like the king of the ether. And it explains why we have to use this more complex way to withdraw earnings than a sort of I don't want to say a naive approach, but what seems really like, hey, just use the transfer function like straight out the gate and that should work. There's actually an exploit there that can occur. And that exploit could basically, you could lock up the smart contract. That's one of the exploits. And so you have to use, so Sean realized that this, if you're looking in the GitHub repo, that's an older, he wrote this in an older version of Solidity. So I've updated the code right here so you can see how it'd be done in Solidity 0.8.x. And what you have to do is you're going to have to basically assign the amount that the high score owner, when it's time for them to withdraw, to a temporary variable, and then wipe the balance in the mapping to say that it's been withdrawn, and then transfer that amount to the high score winner. So this is, I think, really a really clever way of doing it. I think there's a lot of other ways that you could approach this. This is one of the areas where if you're trying to do this, you need to spend a lot of time thinking about how this could potentially be exploited. You would also need to look at all of the different ways that potentially someone could use like integer overflow or other attack vectors to set a high score without playing the game. So I just want to like call that out. It's a little bit outside of the scope of this talk to get into all of that, but I think just sort of hearing that and thinking about that becomes really important. So now we'll get to the last mechanism that was built in this game and continue on this like Web3 journey. Instead of having a score, so in these old school arcade games, that high score leaderboard, the score table, that was stored in memory on the game. You get to put in your name. Sean's approach to doing this was to actually, this entire contract is actually an ERC 721 contract, is extending the Open Zeppelin ER 721 contract. Shout out to the Open Zeppelin folks who are here, if they're still around. There is now when you call the new leader, you're actually able to mint this token so that even if your score gets beaten, even if you're no longer the high score winner, you have an NFT that says, hey, I had the high score. I was a person who at one point in time, had this high score, and I have bragging rights for it, right? There's so many different ways you can extend this, but I think keeping it at its basics, just like thinking about the NFTs as being the leaderboard, and then being able to potentially use a service like Infura to be able to get data on all of the various mintings that occur and actually build a leaderboard into your front end. That is something that you could do for a game like this. So we kind of like showed initially what the new leader function looked like, but now you see that there's been some additional code that's been added. Now, the final thing that you kind of have to think about in this was, and this is just part of like how the Consensus Academy Bootcamp is. Like, we always stress, hey, you need to put in certain mechanisms that if there's an exploit on your smart contract, you're actually able to stop the contract, prevent any other damage. And so that's like a requirement of any project that we end up grading. And so what Sean did in this one was created an owner so that he is the owner of the smart contract, and that he actually has this ability to stop an emergency. So you might have seen on some of these functions that there actually is a modifier to the function called stop an emergency that allows for, if an exploit was found, if you need to take the game out of service for a little while, as that would be sort of the analogy, that he is able to do that. And then also that as a game developer, he is the owner and is able to get what was paid in, about half of that to himself. So this is all done in Solidity, and it was done on, like I said, Rinkeby, but you could see any EVM compatible network. If you're like worried about fees, want to potentially think about like different dynamics that you could add, like this could also work on other EVM compatible networks. So if this was something you wanted to put on Polygon, you could do that. The final thing I'll talk about is like, this is just the start of what you could see as like other dynamics that you can build into games. And there's a lot of edge cases that this project just starts to think about. Like, what happens if two people get the high score, right? What if a high score is tied? What do you do? How do you build in those dynamics? I hope that this gives you the idea of some of the building blocks and some of like the fundamental reward mechanisms, sort of tying back to that old school approach of arcades and how we can extend that into this Web3 space. This was a super fun project for me to see get made and to talk to Sean about. And I think it's something that if you're interested in it, I just want to point you to a few more resources that might be interesting to you. So the first is, if you're just like, hey, I just want to learn how to build Space Invaders, Free Code Camp has an excellent course, Learn JavaScript by Coding 7 Games. They teach you how to build Space Invaders. Also, a bunch of other games, Rock, Paper, Scissors. It's a pretty fun course, video-based. Highly recommend it. Highly recommend Free Code Camp. Great place to, if you're trying to dive into something new, always love to start there. The second thing is, if you are just like, hey, after this hackathon, it's a Saturday, I'm looking for some place to hang out and maybe try and find Seawolf. These are 4 places that I know of that are either arcade or pinball game spots in Portland, the greater Portland area. So I'll leave this one up so you can take a picture of it. As you might imagine, Portland has a lot of cool places like this. So this is not a comprehensive list. There's a bunch more, but these are some spots that I know that are local. They're not chains. They're locally owned. Some of them also rent out games. Like, you can rent them for your party, or if you just want to play that game. The final thing I'll say is that if you scan this QR code, this is bring you to the registration page of Infura. It also will show you all of the. You can also go and see our blog and all that information. If you're building something and if you're using Infura or you're thinking about it, we'd love to talk with you. We love to spotlight folks who are building really anything in this space and give them, particularly with our blog, via presentations, interviewing them, the ability to talk about what they're trying to do and show off a little bit. Also a chance to engage with this amazing community that we have in the Ethereum space and in Web3 in general. So definitely, if you're building something, you're like, hey, I used Infura to get my smart contract up on Ethereum mainnet or Polygon or any other network, please let us know. And the other thing I'll say is, like, there's also other examples of student projects that are up on our blog. For example, a student who built a flash loan arbitrage bot. So there's a series on like going through the process of building that. So thanks again. Good luck to all the hackers. I assume they're probably outside though. Yeah, enjoy. Looks like the sun's out again, so enjoy the rest of the weekend. Thank you.